Okay, welcome back, class, and today we are going to start quadratic equations, section 4. So we're going to talk about the zero factor property, square root property, completing the square, quadratic formula, the quadratic formula, solving for specified variable, okay, and the discriminant, okay, and that also has to do with the quadratic formula. So a quadratic equation in one variable is an equation that can be written in this form. So again, we had a definition for linear equations. Now we have a quadratic equation, right? Definition of a quadratic equation. Now we have a degree of 2. So it's always written in this form, and of course, it has to have a degree of 2, so A cannot be equal to 0. So B and C can be equal to 0, but A cannot be equal to 0. Because again, if A is equal to 0, then we no longer have a quadratic, we have a linear. Okay, so this is standard form for a quadratic equation. Okay, now again, just like I said, it's a second degree equation. So this is a quadratic equation, this is a quadratic equation, this is a quadratic equation, because the highest exponent, the largest exponent on x, the variable, is 2. Now the zero factor property, okay, or what I also call is the zero product principle, okay, because what the zero factor is what we say is in real numbers, okay, or complex numbers, it doesn't matter, that if A and B is equal to 0, not A and B, I'm sorry, if A times B is equal to 0, then either A or B or both have to be equal to 0. That's what I call the zero product principle. The product of both of these is equal to 0. Therefore, A or B is equal to 0. Or what they call the zero factor principle, because you have two factors that you're multiplying together, and one of the two factors, or both, is equal to 0. So either way, it's the same thing. Okay. Okay, so now let's use the zero factor property to solve this thing. Okay. So this is where we have to factor, right? So this is where factoring polynomials comes into play. Okay, this is where factoring is very important to solving it. So the first thing we're going to do is we're going to write it in standard form. Okay. And then now we're going to factor this, and we got to figure out what factors of this thing. So again, these are where that review of factoring comes in, is important, okay? And so if we factor this, we get the factors 3x minus 1 times the quantity 2x plus 3 is equal to 0, okay? Okay, so now, what does that mean? It means either this factor is equal to 0 or this factor is equal to 0. So let's do that, right? So either this is going to be equal to 0, so now we've got two equations that we want to solve for x, and we keep the or. And so if we solve these, right, so we solve them just like we would solve any equation, we find that x equals 1/3 or x equals -3/2. And so now what we have to do is we need to make sure that both of these are solutions by checking. Okay, so it's always a good habit to check that they're solution, because in some cases, like in application type cases, one or both, or maybe none, but maybe one of them doesn't work. Okay, so now a quadratic equation of this form, you can use what's called the square root property, because if we end up with this, well, what we can do is we can take the square root of both sides, because we get this x over here, and then we get plus or minus the square root of k, and then we can solve it that way. That's called the square root property. Okay. And look at that, see? So we could, the square root property says we could take the square root of both sides and we get x is equal to plus or minus the square root of k. But look at this. So if you start with the standard form and you factor this, right? Because think of this as a perfect square, the difference of two squares, where we've got square root of k times the square root of k. And so we can write this as x minus a and x plus a, right? And so we have a difference of two squares, so we could factor it this way. And then again, we could solve using the zero factor property. And so what do we get? We get x equals the square root of k and minus the square root of k. But isn't that the same thing we got up here if we just took the square root of both sides? Okay, so we could have gotten the answer either way, but if you see that you see this, just use the square root property. So then this always gives us this, the square root property. So that is the solution to this equation, if you see that it's in this form, is always going to be this, which also can be abbreviated this way. Okay? So both solutions are real if k is greater than 0 for obvious reasons, right? Because then you get a real number. And it's complex or pure imaginary if, well, they're both complex, I guess you could say, but pure imaginary if k is less than 0. Okay, and so we can rewrite this set as what? Plus or minus I times the square root of the absolute value of k. Okay, because what we can do is we got plus or minus, but k, if k is positive, we get a real number. Okay, if k is negative, we get an imaginary number, and we can rewrite the solution set as this. Okay, so we just get a positive number here, and we just take out plus or minus I. Okay, so remember, if it's an imaginary number, we can write it with an I up front and just make this positive. Obviously, if k is 0, then there's only one distinct solution, and it's sometimes called a double solution. Okay. Okay, so here, what would the answer be? Well, here we're just going to use the square root property, and we're going to take the square root of both sides, and we get the square root of 17, and it's going to be plus or minus. So we get plus or minus the square root of 17. What about this one? Here, we're going to get what? It's going to be plus or minus what? 5i. Okay. What about this one? Now here we can still use the square root property, right? Because we've got a square on one side and a number on the other side. So we can take the square root of both sides and we get what? X minus 4 is equal to the plus or minus the square root of 12. Okay? And then we can continue to solve it or continue to simplify, right? And so this is what we end up with, right? Now we can what? We can add 4 to both sides because we can't have this 4 here. So we can add 4 to both sides to get rid of it. And now we get 4 plus or minus the square root of 12. And we're done. Okay? And of course, always simplify. Now if you factor this, I wouldn't factor, I would just leave it that way. Always leave it in standard form. Okay, so now here's the completing the square. So this is another method of solving a quadratic equation. Okay, so the first step is if the leading coefficient is not 1, you need to divide both sides by the leading coefficient. because you need to have the leading coefficient be 1 to do the to use completing the squares method. Then once you do that, if you have to do step 1, then step 2 is you rewrite the equation so that the constant term is alone on one side of the equality sign. Okay? And then what you're going to do is you're going to rewrite the equation so that the constant term is alone on one side of the equal sign. And then you're going to then square half the coefficient of x. So you're going to take the coefficient on the x variable, you're going to divide it by 2 and then square it. What you're then going to do is add this square to both sides of the equation. Then step 4 is you're then going to factor the resulting trinomial as a perfect square, because that's what we're doing. We're completing the square. So step 3 actually creates a perfect square so that we can go ahead and factor. And then once we do that, then we're going to use the square root property to complete the solution. So let's use this as an example. So here's what we have. So we have this. So the first thing we look at is the leading coefficient is 1, so we don't have to divide by anything. Okay. And now what we're going to do is we're going to take the 14 and move it to the other side. So we add 14 to both sides. And so now we're going to take this negative 4 and we're going to divide by negative 4 and then square it. So negative 4 divided by 2 is a negative 2. Negative 2 squared is 4. So we're going to add 4 to both sides. And what we did was we added 4 to both sides, so we didn't change the equation. But in the process, we created a trinomial that is a perfect square. Okay? And so now we can take the half of this, and then we know it's going to be x minus 2 squared is equal to 18. And now we can use the square root principle property and solve. And so we get x minus 2 is plus or minus the square root of 18. And now we're going to add 2 to both sides. And we get x is equal to 2 plus or minus the square root of 18. And now we can see if we can simplify this, which we can. This can be split into 2 times 9. And we get 3 times the square root of 2. And this is our simplified expression for x. And so this is the solution set. Okay, so there's always 2 answers, right? Plus or minus in this case. So most of the time there's going to be 2 answers. Okay. In fact, there's going to be 2 answers all the time when you're dealing with quadratics. Okay. Let's see here. Okay, so let's do this one. So now we have a leading coefficient. So the first thing we're going to do is multiply everything or divide everything by 9 or factor out a 9. Either way, it results in the same thing. So we can divide everything by 9 to get the leading coefficient to be 1. And so now this is what we get. Now, it looks complicated, but we're going to do the exact same thing. So we're going to move the 1 over here. So we're going to subtract 1 from both sides. And now we're going to take this coefficient and we're going to do the same thing. We're going to divide by 2 and square it. So if we divide by 2, we get 2/3. And then if we square it, we get 4/9. So we get a positive 4/9. And we're going to add that to both sides. And so now we're going to simplify this side, and this becomes a perfect square. Okay? And so all we're going to do is we're going to take what? We're going to take x minus what? X minus 2/3 squared. So we get x minus 2/3 quantity squared is equal to negative 5/9. And now we can use the square root principle. And so now we get this, and so now all we have to do is add 2/3 to both sides, and we're done. Okay, and so this side here becomes I, right? This is going to be I. and this is going to be 5 over 5/9. This is not reducible, but we can get an I out here, and so it'd be 2/3. And this is going to be 1/3, right? So we can make this into 1/3 because we can. This can be -5 times 1 over 9, which reduces to which is a perfect square, and so we can get 2/3 plus or minus 1/3 I times the square root of 5. Okay, and that's what we're doing here. So this becomes this, right? We can split it up. This becomes I times the square root of 5, and this becomes 3. And then, or we can call this the square root of 5 over 3I. And so now we get 2/3, right? So we're going to add 2/3 to both sides, and this becomes our final answer. And so this is it. So now, what about the quadratic formula? So now if we start with our standard form, right, which is ax squared plus bx plus c, then we can use what's called the quadratic formula to solve for any quadratic equation. Okay. Now, in many cases, you're going to want to use the other techniques. But what if it's not factorable? Okay, then the quadratic formula will always work. If you don't want to use completing the square, right? So if we start with this and this general formula, we can use the completing the square steps to derive the quadratic formula. So what happens when you do that? So let's start with this, and what are we going to do? We're going to move the c over to the other side, right? And we're going to divide by a first, right? Because a, we want a 1 here. So the easiest way to get 1 is divide everything by a. And then we're going to basically go through the steps of completing the square, and we will derive the quadratic formula. So the quadratic formula comes directly from the method of completing the square. Okay? And so now this is where a is not equal to 0. Okay, because again, if a is equal to 0, we don't have a quadratic equation, so it doesn't matter. So again, n plus, we can't divide by 0. Okay, so the quadratic formula is this right here. Okay, so this will solve any quadratic equation that you're given. Now, remember to extend the fraction bar in the quadratic formula under the negative b term in the numerator. This division sign, this fractional sign, goes all the way across. Don't forget to do that, okay? Some students will forget this. So let's look at this. So let's put it in standard form. So we're going to use the quadratic formula. So now what we're going to do is a, in this case, is 1. B, remember, it's a plus sign in the standard form. So this is going to be -4. So B is -4. And C is 2. So A is 1, B is -4, and C is equal to 2. And so now all we have to do is plug those values into our quadratic formula. And now, keep in mind, we're doing a negative of B. Well, B is -4, so we're doing the negative of -4. Okay, here we're doing the -4 squared. Okay, the whole quantity -4 squared. Okay, so always be careful of that. Okay, so, and then all you do is stick it in your calculator and simplify. Okay, and so now what do? We simplify the radicand, right? And so when we simplify this, now we're going to factor out a -2 and divide by 2. And so this is then going to end up becoming 2 plus or minus 1, right? So we factor out the 2 and cancels with the 2 in the bottom, and we get 2 plus or minus the square root of 2. Okay? And so there's our solution set. Now what about this one? Well, we're going to do the exact same thing. Let's move this over to standard form. And now we know what A, B, and C are. A is going to be 2, B is negative 1, and C is 4. And so now all we do is we plug it into our formula. Okay, and again, use parentheses to substitute carefully to avoid errors. Very, very important to take your time. Again, negative 1 because B is negative 1, so it's the opposite of whatever B is. So negative of negative 1. Okay, and then of course this is negative 1 quantity squared. So this is negative 1 times negative 1, which is positive. Okay, so be careful. And so now we're going to get this. Now this gives us negative 31. Right? So now this is going to give us an I out here. So it's going to give us I times the square root of 31. And so now what we're going to do is we write this in standard form. And so this is what we're going to end up getting. Okay, so we get 1/4 plus or minus square root of 31 over 4I. Okay, now what about cubic equations? Now, cubic equations are ones that have a degree of 3, right? So the greatest exponent, right, is 3 on the variable. Now, to solve x cubed plus 8, we're going to use factoring and the quadratic formula. Okay, so here's how we would do something like this. So this is actually the sum of 2 cubes, if you look at it, because this is 2 cubed. So this is x cubed plus 2 cubed. So this is a special form. And so what we can do is we can peel off an x plus 2, because this is x plus 2, right? This is the sum of 2 cubes, right? And so this is going to be x plus 2 times this. Okay, and this is a factor as a sum of cubes. Okay, so this is a special formula, remember? So this is the way we factor it. Now we're going to use the quadratic, right? So if we use the formula, right, for factoring cubes, in this case the sum of 2 cubes, then we know this, but then at this point this may or may not be factorable. Okay, in fact, it's not factorable. Okay. So the question, because there's no factor of 4, there's no 2 factors of 4 that will add to negative 2. Okay. So we have to use the quadratic formula here. And so we get this, so we got this part, so that's, we know x plus 2 is equal to this, or this is going to be equal to 0, right? So all we're doing is using the zero product principle here. And so now we've got this is easy to solve. X is going to be equal to negative 2, that's good. Now, but what about this? Well, we can't factor it, so we're going to have to use the quadratic formula. And so in this case, A is 1, B is negative 2, and what? C is 4. And so now we get x is equal to 2 plus or minus the square root of negative 12, which can be further simplified because this is 3 times negative 4, which is 2i. So this is going to be 2i times the square root of 3, right? And so that's what we're going to get. And then we can cancel the 2's here because we can factor out of 2 and cancel, right? So we can factor out here. And now we end up with 1 plus or minus I times the square root of 3. And so this is our final answer, right? So now you can't forget the 2, right? Don't forget the 2. So in this case, we have 3 solutions. We've got negative 2, and we've got 1 plus I, times the square root of 3, and we've got 1 minus I times the square root of 3. So there's 3 solutions here. Now, what about if we have something like this? We want to use each equation for a specified variable. So we want to solve each equation for a specified variable, use plus or minus when taking square roots. So now we want to take this and we want to solve this formula for area, let's say, and solve for D. Okay, let's solve this formula for D. Well, what are we going to do? Well, we're going to multiply both sides by 4, and then we're going to divide both sides by pi, and then we've got a square term that we have to deal with. So that's where the square root principle is going to come into play. Okay, so we're going to isolate D squared first, and then we'll change it to D. So again, we multiply both sides by 4 to get rid of the 4 on the right, and then we divide each side by pi to get rid of pi. And now this is where we're going to take the square root of both sides, and we get the plus or minus. Okay, and now in this case here, we could take the 4 out. Okay, and simplify it. But we also have this square root of pi, and we don't want square roots in the bottom. So we're going to, again, we're going to multiply the top and the bottom by the square root of pi. This is called rationalizing the denominator. We don't want to have a square root in the denominator. So we multiply the top and the bottom by pi, and that's okay. And so this is going to give us pi in the bottom, and then we're going to have an extra factor here in the numerator. Okay, and so we're going to end up with this, right? Simplified this. Now, still not done, because like I said, we can take this and make this into 2. And so this is going to be our final answer, because anytime we have square roots, we don't want to have square roots in the denominator. So we want to rationalize the denominator and multiply the top and the bottom by the radical in the denominator and get rid of it. Okay, now what about this one? Here we want to solve for t. So, but we've got this t squared and this t, so we can't factor it out, so that won't work because we can't isolate it. So here's what we're going to do. We're going to basically what? We're going to subtract k and write it in the standard form. Okay, and then we're going to use the quadratic formula. Okay, where a is equal to r, b is equal to negative s, and what? C is equal to negative k. So here's our quadratic formula. And in this case, the independent variable is t. So instead of x, we'll have t. Don't forget that. And so now b is negative s. So wherever we have a b, we're going to substitute negative s. And so be careful. Okay? So make sure you put it in this way. And then we're going to simplify it as much as we can. Okay? In these types of cases, we may not be able to simplify it very much. So this will become s because the negatives will cancel. This is going to become positive s squared because the negative times the negative is going to be positive. And then, of course, this is negative times negative. That's going to be a positive. So we're going to have some things that will simplify there. And so we get s plus or minus s squared plus 4ak times 2r. And that's it. We're done. We can't simplify it anymore. Okay, now, in example 8, we took both positive and negative square roots. However, if the variable represents time or length in an application type problem, we are only going to consider the positive square root because, remember, it has to make sense, right? And that goes for area, right? You can't have a negative area. Volume of liquids, you can't have negative volumes. So anything in like physics and things like that where you can't have a negative value, it doesn't make any sense, we're only going to take the positive value. Now, the discriminant. The discriminant is the piece or the expression underneath the radical of the quadratic formula. So we can look at the discriminant, which is this value here, this expression, and the value of the discriminant will tell us whether there's no real solutions, okay, and only complex solutions, one real solution, or two real solutions. Okay, so there'll either be 2, 1, or no real solutions. Okay, and if there's no real solutions, then we have complex, right? But we'll get to that. Okay, so that's the discriminant, right? Under the radical, that whole thing. So if the discriminant is positive, then we have a perfect square, and there are two solutions, and they're both rational, okay, or real, okay? If they're both positive but not a perfect square, then you have two solutions, but they're irrational, okay? But both of these are real solutions. So the bottom line is, if the discriminant is positive, then you have a real solution. If it's a perfect square, then you have two rational solutions. If they're not a perfect square, then you have two irrational solutions, okay? If the determinant is 0, then you have only one solution, and it's a double solution, and it's a rational, okay? If it's negative, then you have two complex solutions. Now, be careful. The restriction on A, B, and C is important. Okay, for example, in this case here, the discriminant b squared minus 4ac is what? It's 5 plus 4, which equals 9, which would indicate two rational solutions if the coefficients were integers. Integers, okay? By the quadratic formula, the two solutions are these, which are irrational numbers, okay? So be very careful, because when we use the quadratic formula, okay, and we're looking at the discriminant, okay, look at the discriminant here, okay, oops, bye. Anyway, can't go back on. Excuse me. Remember, they're integers on the quadratic equation, so we're assuming that these are A, B, and C are, if they were real, excuse me, I'm sorry, I got something caught in my throat. If the coefficients were integers, then this would be correct, okay? So you got to be very careful when you're just looking at the discriminant and you're just plugging in these values, okay? Because again, by the way, I don't know if this is a typo, but I don't believe that should be covering the x. Yeah, I don't think that should be covering the x, so I think that's a typo. It should be the square root of 5 times x, okay? Okay, now we're going to evaluate the discriminant for each of these equations, and then we're going to use it to determine the number of distinct solutions and then tell whether they are rational, irrational, or non-real complex numbers. So let's look at the discriminant here. Okay, so remember the discriminant is b squared minus 4ac. Okay, so here a is 5, b is 2, and c is negative 4. And so we're going to we're going to evaluate the discriminant. So we're going to plug and chug, and we get 84. It's positive. Therefore, what? We have a real solution. So it's positive, it's real, okay? So now, but is it a perfect square? It is not a perfect square. So there are two distinct irrational solutions. So remember, if it's a perfect square, we have rational solutions, two distinct rational solutions. If it is a perfect square, or excuse me, if it's not a perfect square, then we have two distinct irrational solutions. Okay, what about this one? Well, let's put in standard form and find out what it is. So here's standard form. So now A is 1, B is negative 10, and C is 25. Now notice here that this is a perfect square. You can tell because if you take the square root, if you divide this, by 2 and then square it, you get 25. This is a perfect square. Okay, so I already know that this is going to what this is going to give me, but let's do it anyway. So the determinant is 0. Look at that. The determinant is 0, and so we've got a double root, a double solution. That's the same, right? One distinct rational solution that is a double solution. So that is, remember, because you get a perfect square here, that means, remember, you've got one solution that's repeated. It's a repeated solution. Okay, now what about this one? So here A is 2, B is -1, and C is 1. Okay, so now we're going to evaluate the discriminant, get -7. Okay, -7, that means there are going to be two distinct non-zero complex roots. Okay, or in other words, complex conjugates. Okay. Okay, and that is the end of this section. So again, make sure you're practicing. If you go back through these, if you get stuck, go back through them. There are other examples in the textbook. There are examples, there are problems at the end of the chapter and such. There's also the suggested homework problems. Again, remember, those are going to be important to know how to do because, again, I take my quizzes from those. And, oh, you never know if they'll show up on an exam. So always practice those and bring them to class. If you get stuck, we're going to be working on them too in class, but obviously we're not going to be able to get through them all. But again, if you're working outside of class and you get stuck on something, bring that to class. That's what class time is for. So if you have any questions, email me or bring those to class as well. I'd be more than happy to cover that. Anyway, have a great day and I'll talk to you later. What's up?